Today, our topic is outliers. Our topic is outliers. Outliers are numbers that are way far out of the norm, and they sometimes skew or make the data rather unreliable. For example, if I was to add up all of your ages and do the mean, divide by how many you are, we'd get something around 15 or 16 or something like that. Well, if Mr. Malachi would come in and we would calculate the mean, it would be significantly higher because we are adding his age in. That's an outlier. That's an outlier. If we were to have one of our former students, and some of you know Adam, the Viking Adam Thielen, does any of you live next to him? Some of you probably do. All right, real nice guy. He married a girl from this school. He waited until she was a grown woman.
Oh,
but
my aunt was best friends.
yes, they were soccer players. Anyways, Adam's a nice guy. Those of you who've met him, he treats people well. He also makes millions more than most of us, okay? If we were to figure out your average pay per hour in here, you know, it might be 11, 12 bucks an hour, depending on some of you if you're getting the good or not. If Adam were to come in here and we figure out the average pay per hour, the average pay per hour in here would probably be about $800 an hour. All right? Well, with him it is. Well, no, with him it's way more than that. But be like $800 an hour. Would that be representative of this group of people? His huge amount of money would make the day, you know, this class average is $800 an hour. Well, that's true if he was here, but that data wouldn't really represent that most of you make probably between 8 and 15, all right, or maybe a little more. Blake Johnson, a little more, did you say? No, yeah, okay. All right, 15, some 16s. But none of you are making millions a year, which divides into a lot per hour. All right. So, there are two ways that we can find outliers. And we're going to go over the first way first, and the second way second, and then do it the hard way. The first way is called this. So, instead of just saying, oh, okay, so it's very obvious that Adam Thielen's money would be an outlier, that is way more. But if, for example, the people that work in the lunchroom were coming in here, maybe what they make would seem really high in this class, maybe it'd just be a little high. If we are talking about the ages of you people, and Mrs. Castleberry came in, she's a rather young teacher, would that in fact be an outlier that's like way out, or would it be sort of close enough? So here is how we do it. First way, please write this down, the IQR method. This is the interquartile range. You don't need to know those words. Interquartile range. What it's going to be is sort of figuring out how spread out the data is around the middle. So your first step is the following. The IQR is an easy calculation. It's Q3 minus Q1. Now forget about all the funny letters. It's just a silly subtraction. Say, did your calculator show you what Q3 was? Yeah. Did your calculator show you what Q1 is? So you're just going to write RQR and you'll just subtract those two numbers. Then we have one more. It's going to be called the lower fence. Sometimes they use a different word than fence. And the lower fence will be this. Any data below that number will be an outlier. And it's not too hard a calculation. The lower fence is simply this, is Q1 minus 1.5 times IQR. Yes?
So for like IQR, you know how it's like Q3 minus Q1?
It's not always the same. Sometimes it turns out to be that, but sometimes it doesn't. Just depends on the numbers. Say, okay, icky letters, however, Q1, is that just a number that's staring at your calculator? Minus 1.5 times what you just calculated. That's actually not a tough calculation, is it? What's up? It is not. It's not. Just on rare occasions it is, but it sometimes is not. The upper fence, so anything above this number would be an outlier, is the following. It is Q3 plus 1.5 IQR. All right. It's not, if someone walks into the room right now and sees this, they go, "Bleh." Well, usually people, when they walk in this room, say that anyways. "Bleh." Okay. Let me see here. All right. You put a bunch of numbers in your calculator. This is going to be called our first example. You put a bunch of numbers in the calculator, and it says Q1 equals 50, Q3 equals 80. All right, it says a whole bunch of other things, but we found Q3 and Q1. Did we do that yesterday? Say yep.
Yep.
All right. So your solution is the following. You go first step, IQR, interquartile range. It's just how spread out are the middle numbers, is simply 80 minus 50 equals 30. All right. Okay, IQR, silly letters. However, is the Q3 just staring at you in your calculator? Is Q1 staring at your calculator? All right. Now you write lower fence equals Q1, 50, minus 1.5 times IQR times 30. In your brain or in your calculator? The lower fence is 5. So if you'd look at all the data, anything below 5, you'd say that's an outlier. And then you write upper fence. And the upper fence, you look at the formula. I'm not going to have you memorize these. Is Q3, it's staring at you, 80 plus 1.5 times this IQR thing. I'm hearing 125. So then, if we had a list of numbers, you would say anything that's below 5, you'd say that is an outlier. Anything above 125 is an outlier. So now we're not just saying something really big or really small, we're having a specific. That's not going to be too bad, is it?
No.
The next way is called the standard deviation way. It's a different way, and it's equally as easy, just with a whole bunch of letters and numbers and stuff like that. It's just as easy. The other method is called the standard deviation method. And that little symbol is a small Greek letter meaning sigma, which means standard deviation. The real basic words for standard deviation is another way of saying how spread apart are the numbers. For example, in this class right now, forget about me, which most of you do all the time anyways. Your ages, are they pretty close together or are they spread apart? They're pretty close together. Now if you go to the mall and find just 35 random people, would the ages be much more spread out? Yeah. Yep, you'd have some younger and older people that we don't have in here. That would be more spread out data. If we were talking about the people that work at the Target store, probably pretty close together, you know, maybe 12, 13 up to 15, 20. Maybe the boss is making a bit more. If you'd go to the Vikings game and the people making money there go from probably $12 an hour to $500,000, right? Because you got people selling concessions and people playing the game. That would be a huge standard deviation. All right, standard deviation, that's its symbol. And it is actually the Greek letter small sigma. How many think you're going to be fraternity or sorority kids in college? Well, you already know some Greek letters, because usually they're like Greek houses, like Sigma Sigma Tau or Delta Sigma Pi.
Can you make your own sorority?
You should try. All right, the outlier. The lower fence, and this is going to have a lot of notation, but it's easy. The lower fence is X bar minus 2 standard deviations. Hey, X bar, one of our is the mean. By the way, those of you in video land, some math teachers think it's 3 standard deviations. There's different methods to go about it. We'll go with this one.
Wait, two what?
2 of these little sigma, 2 of the standard deviations, which will show up on your calculator. And the upper fence is X bar plus 2 standard deviations.
How do I know, like, when I'm answering a question, if I'm trying to answer will it be pretty obvious?
It'll directly say, Do I need to stop this recording yet? 3 minutes, I can finish in 3 minutes. Here's our example of the standard deviation method. It goes like this. Your calculator says the standard deviation is, the mean is 46. Your calculator says the standard deviation is 3.8. So your calculator says that. Yay, calculator. The lower fence is simply 46 minus 2 times 3.8. The upper fence is 46 plus 2 times 3.8. I'm going to stop the recording because I'm running out of time. Goodbye at home, people.